All right, welcome back to part 3 of our discussion of stoichiometry. Today we're going to be talking about limiting reactants. So generally, what will happen is as you go through a reaction, one of the reactants in the chemical reaction is going to end up being used up. And then you'll have some excess of the other one left over. Up until this point, we've been telling you about one reactant and just assuming that the other one was left in excess. Today, you're going to have to be able to figure out which one is in excess and which one is limited. It's just like if you were to go to your fridge and you wanted to make a whole bunch of ham and cheese sandwiches. You'd have to get your loaf of bread, you have to get your ham and your cheese out. And you can keep making those sandwiches until, let's say, your cheese runs out, and then you would have excess bread and excess ham left over. So in that situation, then your cheese would be your limiting reactant, and your excess reactant would be your ham and your bread. So the steps for this, just like the other one, we always start with balanced equation. We're going to use the amounts this time from all the reactants, and we're going to move them up into 2 clouds if there's 2 reactants, or however many clouds we need to be able to figure, to be able to work with this. Then you're going to figure out which one is the smallest amount, and that cloud stays, and the rest of the other clouds go away. And then you are going to calculate the rest of your chart based on that smallest cloud. So let's start off here with our first example. Here we have sulfur. Sulfur is going to react with chlorine, and we're going to have sulfur dichloride produced. So we're going to write in our, I don't know why that flipped on me. There we go. Let's try this again. So we've got our S8 here, plus our 4-chlorine, and that's doing that to me again. Okay, try that again. Plus our 4-chlorine. And that's going to produce 4S2Cl2. And then we have an extra row here that we don't, or column that we don't need. All right, so the first thing we're going to have to do, again, only moles in the holes. So we've got to calculate how much sulfur this is going to be. So we're going to divide this by the molar mass, but this is the molar mass for S8. So the molar mass for S8 is 256.8, and then that's going to give us a mole value of 0.779. And just like I mentioned in the previous video, you always want to make sure that you have at least 3 significant figures in this chart at all times. All right, our chlorine, we're going to divide that by 70. Why is this doing this? I'm so sorry. Okay, so we're going to divide this by 71 because remember chlorine's a Brinkelhoff, so we ended up having Cl2. So when we divide that by 71, we get 1.41 moles here. Then we're going to end up making 2 different clouds. So we've got one for the chlorine. So when we take the 1.41, we're going to bring that up into the cloud. And remember, when we go up, we divide. So when we divide that out, 1.41 divided by 4 is I did it again. All right, let's try that again. It's 0.352. And our cloud for our S8 then ends up being, we're going to divide that by 1, so that ends up being 0.779. All right, so since this is the smallest cloud, or the bigger cloud, we're going to keep our smaller cloud here, and we're going to get rid of all of our bigger cloud, and this is the number that we're going to be working with for the rest of the time here. So if I take this value then, and I bring it down out of the cloud here, I'm going to multiply by the 1 coefficient, and that's going to be 0.352. Then I'm going to take this down here, which would end up being 1.41. That's a subtraction there too. Over here at the beginning of our reaction, we didn't have anything here. So 0 for our amount here. Here we take this, we multiply by 4, we get 1.41, 1.41. This we end up with 0. And here if we subtract, we end up with 0.427 moles. All right, so these are mole values. They did want to know the mass of this disulfur dichloride. So we need to take this value out as a moles. We're going to take this value out as the moles, and we're going to multiply that by its molar mass. So the molar mass of that ends up being 135.2. Yeah. So that ends up being, so we're going to take that, we're going to multiply that by 135.2 because it's grams per mole. That's off the periodic table. And so that means that we have formed 190, and it's 4 sig fig, so 190.4 grams of S2Cl2. And that ends up being our answer. And I'll just leave that guy there as part of our line. All right. So the next one then, they did not give us a balanced equation. So we're going to have to balance this equation out. And when we do that, it tells us that we have P4. And that's going to react with oxygen. We are going to end up forming P2O5. Oh, that's its empirical formula. Hold on. This is its molecular, so I got to erase that. Sorry. Okay, so that ends up being P4O10. Technology. Okay, so balance the equation. The only thing we have to do is put a 2 here and we'll get it balanced. All right, so they're telling us that we're starting out with 25 grams of this. If I take that and I divide it by the molecular mass for P4, which is 124, I'm going to end up with 0.202. 0.202 moles. Here, I'm going to take my 25 grams, I'm sorry, my 50 grams of oxygen. I'm going to divide that by 32 because we have O2 here. And if I divide that out, I get 1.56. So then I'm going to go up into my clouds. I'm going to have 2 clouds here. I'm going to have my oxygen cloud. So 156 divided by 2 ends up being, I'm sorry, I put a 2 there. That should have been a 5. Did not balance that correctly. Sorry. All right. So if I take that and I divide that by 5, I end up with 0.313. Over here, I'm going to have this divided by 1. So that's 0.202. So which one is the smaller cloud? This one. So this is our limiting reactant. We can get rid of this guy here. So he can go away. And that means that we're using 0.202 for the rest of our calculations. So if I take 0.202 and multiply it by 5, I'm going to end up using 1.01 moles of oxygen. Over here, I'm going to use all of this. I didn't have any of this to begin with, but I am going to take the 0.202, multiply by 1. That's 0.202 here. And then I'm going to end up with 0.202 moles here. Here I won't have anything. And then here, once I subtract, I end up with 0.55 moles for my oxygen. All right. So they wanted us to determine the mass of this. So if I take that and I multiply by its molar mass, so the molar mass for P4O10 is 284. So I'm going to multiply by that. That means that I'm going to have 57.4 grams of P4O10 formed for my final reaction. All right, good enough. They want to know how much of this excess reactant is left. They didn't ask us for mass of it. So if we wanted to, we could just write down 0.55 moles. But if we wanted to calculate the mass, all we have to do is multiply it by 32. And the mass of that excess reactant then is 17.6 grams of O2 in excess. So that is our second answer. So answer 1, answer 2. Okay, let's move on to our next problem. Next problem deals with sodium. And we've got sodium and iron 3 oxide, and they're reacting. And they want us to figure out our limiting reactant, our excess reactant, how much we've got left of that, the mass of the iron that's produced, and the mass of this excess that's produced. All right, so they've already given us the balanced equation. We just need to copy that down into our chart. So 6Na. And then we've got Fe2O3. Oh, that erased everything. Well, I guess we're starting over. All right, let's try it again. 6Na plus Fe2O3. We've got 3N. Well, we'll just stick with that. Na2O and 2Fe. All right. So we're starting out with 100 grams of sodium. So we need to divide that 100 by 23 because that's the molar mass for sodium off the periodic table. And that ends up giving us 0.725 moles of sodium. We have Fe2O3 here, and we're going to divide that by the molar mass for iron 3 oxide. The molar mass for that is 159.6. So if I divide that by 159.6, I get 6.27. So now I'm going to take these up into the cloud. I've got two clouds here. I've got my Fe2O3, and I've got my sodium cloud here. My sodium cloud, I need to divide this by 6. When I do that, I get 0.121. This guy, when I divide it by 1, is 0.627, which means that sodium is my limiting reactant because it has the smaller amount in the cloud. So we get rid of this guy. I'll try to get rid of that. Again, this is the cloud we're going to use, and I cannot seem to be able to get this to stop doing those long lines. There we go. Success. All right, so I'm going to bring that down out of my cloud. When I bring that out, I have to use all of this up. I'm going to bring this down. I'm going to minus 0.121. Here, I need to take this and I need to multiply it by 3. Multiplied by 3 is 0.362. And here, I need to multiply it by 2. And that ends up being 2.42. So that's how much I'm going to make of these in mole value. Here, when I subtract these values, I end up with 0.506 moles. And I need to multiply that out. They wanted to know the mass of that excess reactant. So I'm going to multiply that by its molar mass off of the periodic table. And that ends up being 159.6. And when I do that, I end up with 80.7 grams excess. Over here, they wanted to know the iron, so we need to multiply that by 55.8. That's the value of iron off the periodic table. And when I do that, I end up with 13.4 grams. So if we go back and we look at our limiting reactant was sodium. Our excess reactant was our Fe2O3. The mass of our iron produced was 13.4 grams. And here our mass of our excess reactant was 80.7 grams.